Good day, students. The topic we are treating today in chemistry is solution. Actually, this topic is under solubility. Then we are going to look at the types of solution and examples of solution. Then we'll look at the practical aspect. What is a solution? A solution is made up of a solute and a solvent. Now, solutes like salt, when added to water, form salt solution. So a salt solution is an example of solution. Now, the solute there is a salt. That's the substance you are dissolving. At times, it's possible to get liquid as a solute. And what you are using to dissolve that solute is solvent. Now, it's possible to get solid as a solvent too at times. We have different kind of solvent, but this is water as an example, and this is salt. Salt is a solute, water is a solvent to give you salt solution. Now, a solution can be homogeneous, meaning that it contains one type of salt. When it is heterogeneous, it contains different kind of solutes in the solution or different kind of salts. Now, we also have different types of solvents again. We have polar solvent and organic solvent, non-polar solvent, organic solvent. Then we have polar solvent. A very good example of a polar solvent is water. Water is polar. That is, it has hydrogen ion and hydroxy ion. So because water is polar, anything that will dissolve in the polar solvent should also be able to ionize in water. Water is a universal solvent because it is used to dissolve most substances, except for some substance that does not dissolve in it. Even some organic compound still dissolve in water as a polar solvent. Now, any substance that dissolve in water will form an aqueous solution. We say that substance is an aqueous solution. Why any substance that does not dissolve in water but dissolve in other kind of solvents like petrol, benzene or turpentine and so on, those ones are non-aqueous solution. Just like I said we have polar solvent and non-polar solvent. Polar solvent is water, while non-polar solvents we have kerosene, petrol, benzene and turpentine. These are also known as organic solvents. Now, what are the uses of these solvents? Solvents can be used in laundries and dry cleaners, like the fats, oils, grease stains are removed by solvents like petrol. You just use petrol to dissolve the fat or the stain. Paint stains are also removed by turpentine, and then coffee or tea stain are removed by borax in water, by a solution of borax in water. Now, in the manufacture of perfumes, oils are also dissolved in ethanol. Ethanol is acting as a solvent while oil is a solute. And in the laboratory, chlorophyll is extracted by boiling the leaves in ethanol. That is, we use ethanol as a solvent, while the chlorophyll is extracted from the leaf, the green pigment, using ethanol. We have a lot. Turpentine is used to mix waterproof paint for painting of walls. Then water, being a universal solvent, is very suitable for most chemical reaction, even the living system like in the body of man and animals. It is also present in the blood. Iodine solution for dressing wound, for instance, now is prepared by dissolving iodine solid in ethanol. Now, what are the other types of solution? I said it's possible to get a solid as a solvent and even another solid as a solute. We have different kind of solution. To get brine solution, for instance, brine solution, we dissolve sodium chloride, that's your table salt that you use at home, dissolve it in water. Water is a solvent, sodium chloride is a solute. To get antifreeze solution, you dissolve alkanol. Alkanol is a solute, while water is the solvent. Now, to dissolve soda water, to get soda water solution, which is a weak acid solution, just dissolve carbon dioxide in water. You get a weak acid solution, which is soda water. Water is a solvent there, while carbon dioxide is a solute. To get brass, which is an alloy, a mixture, you can dissolve zinc and copper. Copper will act as a solvent. It means copper is in high concentration, while zinc is in low concentration as a solute. Mix the two together in solid form, you get brass when melted and reformed or reshaped. Then in air, nitrogen is present in abundance in the air, so it's acting as a solvent, while we have oxygen. Oxygen 21%, nitrogen 78%. So oxygen is acting as a solute, while the air is acting as a solvent. So these all form solutions. We have different kind of solution, just like I said. Now, we are moving to another phase, which is the major types of solution. We have the true solution and the colloidal solution. Now, how do you get a true solution? When you dissolve a solid, take for instance, I'm dissolving salt in water. Now, after dissolving salt in water, you notice that a clear solution is being formed. When you dissolve a solute in water, solute particles, that they are able to get in between the solvent particles, you get an homogeneous solution. You can see that we are not seeing the salt. Everything is dissolved. We are not seeing it. The solute particle is able to get between the solvent particle. We get a true solution. This is a true solution. You can also use copper sulfate. You can see this is a solution. It's not just water. It's a mixture of salt and water. Now, we can also use copper sulfate, which is copper tetrasulfate 6, is white. Although when it comes to contact with water, it turns to blue. But the solution will be a blue solution. And the blue solution will be clear like this. It will be clear, not cloudy. It will be clear. That's a true solution. One thing about true solution is that when you shine a beam of light through a true solution like this, when a beam of light passes through, you can see that it will not scatter the beam of light. The beam of light will pass through. We see the reflection of light through the water. So a true solution does not scatter light rays. But a false solution, which we all know now, a false solution will scatter light ray. That's what we call Tyndall effect. Tyndall effect. Scattering of light rays by false solution is a Tyndall effect. Now, how do we get a false solution? This is a true solution. You can see that the crystalloid, like the salt that dissolve, is not, we can't see it with our naked eyes. Now, how do we get a false solution? We call a false solution colloidal solution, a colloid. A colloid is large enough. The solute particles are also larger than the particles of the true solution, like the salt, but not large enough to be seen by the naked eyes. Anyway, you can't see it with your naked eye. Some examples of colloids are the starch and the albumin. That's the white part of the egg and the starch. Unfortunately, I don't have that here, but I have different kinds of colloids. Colloids are known as false solution. There are different kinds of colloids. How are colloids formed? Colloids are formed when a liquid solvent, that's what you are using to dissolve another thing, which is known as dispersion medium, the medium through which something will pass through, that's a liquid solvent, is used to dissolve a solute particle, which is a dispersed substance. I'm dispersing a substance in water, for instance. Now, if I'm dispersing an air spray now, for instance, maybe air spray which is in liquid form inside the container, that air spray which is in liquid form is a dispersed substance, and I'm dispersing it through the air. The air is the dispersion medium. Now, we have different kinds of colloids. We have the salts and the gels. Salts and SOL and gels, GELS. Now, salts are, when salts are formed, when they get dried, they become gels when they solidified. Now, the most common type of salts, or how salts is formed, is when a solid particles are dispersed in liquid medium. Take for instance your starch, your white starch, uncooked one. When you dissolve it in hot water, it will form a sol, watery gel. But when this gel solidifies, it becomes a real gel. So salts solidifies to become gels. Salts is formed when you dissolve solid in liquid. Solid in liquid. So the liquid is a dispersion medium, while the dispersed substance is a solid. Anyway, we can get different kind of colloidal solution. A dispersed substance can be a solid, liquid, or gas. I'm going to be giving you examples now. So for salts, now we call salts solid, liquid, colloidal system. Now, examples of salts are the starch, the glue. This is a glue. Now, most glues are formed when you dissolve all this foam, or this foam that we use to pack electronics. You dissolve it in petrol, you can get a glue. So this is like solid in liquid. Petrol is a liquid, that's a solvent, and is a dispersion medium, while the solid is a dispersed substance. We also have examples of salts again. We have jelly, we have clay. This is dissolving a solid in liquid to get a gel, a jelly, like the hair cream. Now, we also have clay. Clay is also another example. Now, aerosols. Don't forget I said salts are formed when you dissolve solid in liquid. This liquid is a dispersion medium, while the solute is the dispersed substance, which is a solid. Now, for aerosols are formed when you spray a liquid in air. Air is a medium, while the dispersed substance is a liquid. Take for instance now your air spray, and this is an example, only that this one will form something else. Now, when you spray this is what is usually formed. Although this is a liquid, by the time you spray it, it passes through the air and it looks like a gas, but it's not a gas. Actually, it's not a gas. Now, a liquid in air is aerosol. A very good example of this is the spray of insecticide or deodorants. They are one. The examples of aerosols are fogs and smokes. How has fogs formed? The gas is the air, while the liquid water that passes through the air is dissolved in the gas, so to get fog. For smoke, solid like the ash will pass through the air. The air is the gas. The air is the solvent or the dispersion medium, while the solute or dispersed substance is like the ash that passes through the air to get smoke. Now, for your foam or lather, the gas is a solid, while the liquid water is the dispersion medium. We also have another types of colloidal solution. I've given you two examples of colloidal solution, which are also known as false solution. Colloidal solution is known as false solution. We have in colloidal solution, we have the dispersion medium and we have the dispersed substance. I said we have salts and gels. I've given an example of like starch, like the glue, like the gelatin clay. Then we have aerosols, which is the insecticide, spray of insecticide. We also have, under aerosol, we have fog and smoke. They are also examples of insecticide. For emulsion now, emulsion is another type of colloidal solution. When emulsions are, how do we get emulsion? A liquid, if an emulsion is gotten when you dissolve a liquid in another liquid. Take for instance your liquid milk, evaporated milk dissolved in water will get a dilute milk. This is an emulsion. You can see how smooth it is. This is an emulsion. We also have cod liver oil emulsion. We have hair cream, that's if the hair cream is watery. We have milk. These are examples of emulsion. When you dissolve liquid milk in water, you get that. Hair cream, how are the hair creams? So when you develop different kind of mixture which are in liquid form, you dissolve it in another liquid. For your cod liver oil, the same thing is formed. Butter is a solid emulsion. Yes, you dissolve fat in you hydrogenate fat anyway to become soft, and is a solid emulsion because it's more or less like a liquid. So liquid particles are dispersed in a solid medium for butter. But for other example, liquid in liquid. Now, from there we move to suspension. That's another type of colloidal solution. Don't forget that these colloids cannot be separated by filtration. We cannot filter them. Even through solution, except you eat a true solution, you get your solute out, like your salt. You can get your salts out. This is a clear solution, it's a true solution. While other ones that I've given you the examples of what? False solution. For your suspension, this is an example of suspension. You can see that the particles are still settling down. Things like dissolving paracetamol in water. You also have antibiotics, is a suspension. You see particles of what you dissolved in the water. Now, how are suspensions formed? The dispersed particles can be seen with the naked eye. You can see the solutes can still be seen with the naked eye. If the suspension is left undisturbed, the dispersed particle eventually settle down, which you are seeing is settling down, leaving the solute. You can see it. You can see the particles. See the particles, they can be seen by the naked eye. Suspension is an heterogeneous mixture of undissolved particles in a given mixture. The particles are usually large enough to be seen by the naked eye, and they eventually settle down when left standing. Now, the harmattan is an example of suspension, the one that blows from the Sahara Desert towards the West Africa during the dry season. This is an example of suspension. You see dust particles blowing through the air. That's solid in liquid, and the solid is not dissolving. And at a point, you see that these particles will go and settle on surfaces of buildings, cars, even on your body. You see sand, you feel sand on your body, on buildings, on plants. Even on the body of plants, you see sand on body of plants. So harmattan is an example of suspension. In some suspensions, the particles are too small to be seen. They appear to have dissolved in the medium and may not settle on exposed surfaces. Now, those ones are borderline between suspension and colloidal solution. We describe those ones as colloidal suspensions. They have both the characteristics of colloidal solution and a suspension. Example is the cloud, the fog, the smoke, the aerosol spray. The characteristics of true solutions, colloidal solutions, and suspensions are due to the size of their undissolved or dispersed particles. Don't forget I mentioned Tyndall effect. All these four solutions, when you pass a beam of light through them, they will scatter the beam of light. The beam of light cannot pass through this. It will be scattered. But a true solution, the beam of light will pass through undisturbed. It does not scatter light rays. So Tyndall effect is actually the scattering of light rays by a false solution. So in the next video, we are going to treat saturated and non-saturation, and we move to solubility calculation.